This video is on ways to use the Pythagorean identities. Let's do a quick review on what the Pythagorean identities are. Here are the three of them. You have sine squared of theta plus cosine squared of theta is equal to 1. Quick reminder that this right here, sine squared of theta, is basically sine of theta times sine of theta. So there's our first Pythagorean identity. Then you have your tangent squared of theta plus 1 is equal to secant squared of theta. You have 1 plus cotangent squared of theta is equal to cosecant squared of theta. All right, so those are our Pythagorean identities. How can we use them? Well, one way we can use Pythagorean identities is if you're given the value of one of the trigonometric functions. So either sine, cosine, tangent, cosecant, secant, or cotangent, you can use that value to basically find the exact value for other trigonometric functions. So if you're given one of those six, you can use that value to find the exact value for the other ones. Let's do an example here. So let's say that you're asked this question. Determine the exact value of cosine if sine of theta is equal to 2/3. So here we know an exact value for one of the trig functions, and we're asked to find another one. So quick reminder, we're working on basically a unit circle here. It's the trig functions are related to this unit circle. And here, our problem is asking us about sine and cosine. And on the unit circle, cosine is equal to the x position, sine is equal to the y position. So the problem said if our y position is about 2/3, so that's right around here, what will our cosine value be? So that would be this length right here. So we know it's going to be around somewhere near 0.7. Okay? So the thing is that there are actually two different places on this graph where your y is equal to 2/3. You have this place right here, P, and you have over here, this position over here. So if our point P is over here, if our point P is over here, then sine is equal to 2/3, and our cosine is equal to whatever this length is here. But I can move this over to this side. My sine is still equal to 2/3, and my cosine will equal that length, which is basically, it looks like the negative of this length over here. Okay, so now that we have a rough idea of what the answers will look like, we know that there's going to be one answer here in our in quadrant 1. We know one of our answers is going to be over here in quadrant 2. Just for the record, down here, this is quadrant 3. And here is our quadrant 4 over here. So we know we have one answer in quadrant 1, one answer in quadrant 2. Let's go back and now solve it. So since I'm going to use the Pythagorean identities to solve this, And since the problem has sine and cosine, I know I'm going to use this somehow. Let me just put this over here to remind myself. All right. So I know that this sine squared of theta, just a reminder, that just meant sine of theta times sine of theta. So, and I know that I want to type out each little step. Okay. So, and I know that my sine of theta, this sine of theta here, is equal to 2/3, exactly. So let me substitute that in. This sine of theta is 2/3, this sine of theta is 2/3. So I know that 2/3 times 2/3 plus cosine squared of theta is equal to 1. All right, let's continue. Multiplying fractions, I multiply the top. 2 times 2 is 4. 3 times 3 is 9. All right. So once again, reminder, we're looking for cosine of theta. I'm going to subtract 4/9 from both sides. All right. This will, on the left side, 4/9 and 4/9 cancel each other out, and you're just left with cosine of theta, cosine squared of theta. On my right-hand side, I know that 1, if I want to subtract this, I want them to have the same denominator, the same number in the bottom, and I know that 1 is the same thing as writing 9 divided by 9. So now that they have the same number on the bottom, the same denominator, the way you subtract fractions is that the bottom stays the same and the top becomes 9 minus 4, or 5. All right, so finally you have cosine squared of theta is equal to 5/9. And I know, and I'm looking for what does cosine of theta equal. It's going to have 2 different answers here because of that squared. So I will square root both sides, square root that, square root that. On the left-hand side, the squared and the square root cancel, and then you're just left with cosine of theta. On the right-hand side, this will be 2 different answers. You'll have square root of 5/9 or negative square root of 5/9. So this is, in fact, 2 different answers. You have this positive or you have the same thing, but where the cosine is negative. So there you go. There's your exact answers for what cosine of theta would equal if sine of theta equals 2/3. And this is sort of about what we expected. Remember when we looked at our unit circle, we knew that we were going to have one answer that was negative and one answer that was positive about the same amount, or exactly the same amount.